an introduction to BGS and around our digital strategy, which is what I've been asked to talk a little bit about. And I really want to emphasize the importance of data and visualization to the future of the Geological Survey and where it will be going in the next decade. So Karen Hanhoy has already mentioned, given you the vision and the mission statement of the Geological Survey. I think the key thing I want to emphasize on that is it's working with new technology and data to understand and predict geological processes that matter to people's lives and livelihoods. At the center of that is new technology and data. And at the center of that is how do you visualize that data in ways that people can start making decisions? Because a geological survey, a public sector research institute, is not about telling you what your decisions are. It's about providing the information for those people that we have either voted in, like politicians, etc., that are making those decisions, to have that information in easily understandable formats. At the Geological Survey, we have a range of information that is massive. And the key thing I want out of this slide is to show you that we really connect our samples and archives, so our analog collections, with our digital collections. So these digital proximities of our rocks, our fossils, our reports are all interlinked together. We provide, 25 data sets that are downloadable under OGL, which are our mapping data sets. And I'm going to talk a little bit more about our maps and where we're going with those in the next few slides. So over 7,000 BGS maps are published on our open geoscience. So there's a huge amount of data and wealth of data and information available. So the Geological Survey has a mandate to supply geological information. And we talk a lot about being authoritative data providers. So what does that mean? It means that we are accountable for the production, provision, and quality of our data. We are the only providers of geological information in the UK, or the only official providers of geological information in the UK. We have a mandate to produce, process, and issue our data. Our data has to be trusted by our users in the long term, and that's very at the heart of everything that we do here. We have to standardize our data following international standards, and we've already touched this morning on different standards that people are using, but this is really important when we're talking about reusability and interoperability within geospatial and map data. Our data has to be of a high quality, and it has to be accessible and reusable via portals and platforms in formats that people need. And that also means us looking at developers and what they need. So the whole new ways of using data and how we stream data to people and the different types of users that are coming on board now is really important and defining and shaping our digital strategy as we go forward. I would say that there are a number of challenges and opportunities that we are looking at. Big data and fair data, which I will talk about in a little bit more detail. Obviously, there's always the cyber threat. I think the big things here are around open source and open technology and how we can harness those, how we collaborate, and the types of ways of collaborating and sharing data is a big move forward and really changing the way that we look at our research infrastructure going forwards. There is a need for simplification of our digital systems, and that's the other thing, in consolidation. So there's been a proliferation and a huge amount of innovation within geospatial data over the last few years, and now it's about consolidating those into more mature frameworks going forward. So in using those opportunities, the key part of the digital strategy is about making our past part of our future by moving our analog collections so that they can be used for machine learning and data science techniques, to link our information systems together, improving that data flow from ingestion to service delivery. So again, about our analog collections into our digital collections, transform how we work within BGS and with the wider UK and global communities. How can we use the digital technology and emerging technology coming forward to make it easier to work with us, to collaborate better, to co-design our solutions better? The Geological Survey last year in 2020 produced its first digital strategy called Creating a Digital First Geological Survey. And I've highlighted here for you to see the vision and our mission. So to create a digital first geoscience organization. And you'll note here, the really important part here, it's about linking people, data, equipment, and technology together to make those new influences. So a digital transformation is as much about the people and how we all work together as it is about the technology. And that's at the heart of how we're doing. So when you look at our mission, the point that I wanted to highlight to you is that we will develop user-focused solutions. So it's about putting people at the heart of a digital transformation. It's about understanding how people use our data, how people are working with us, how our scientists want to use data, so that we produce better, more accessible data services going forward. As many of you will know who have been with the survey with us for many years, will know that throughout my career, we've had a quiet evolution from traditional survey maps right now through to mathematical and conceptual models, much more these days in the 4D with time series data coming into it, as Karen mentioned earlier. That transformation has meant that we have changed radically how we are communicating our information. The realization that less than 2% of the population understand geoscience, and therefore, 98% of the population do not understand a geological map, has meant that we have had to change how we communicate that information. But you'll also see how important the visualization of that data is to our future. When you're looking at, and this is an example of London and the Thames Estuary, at providing an understanding of three-dimensional geology so that you can start to understand that London is not got simple geology. Its geology is actually very complicated and highly faulted and highly complex. The only way you can really view that and understand that is through using 3D visualization of map data. The other thing that we've been doing, this was released in March 2019, was our regional 3D models, which you can all download off our internet now, providing our users with a modern take on the geological map. So now that you can cut it, you can look at it, you can view it in different angles, you can start to understand what the 2D representation of a complex three-dimensional space actually is. And if you're a non-specialist, this is really, really important. The other thing that we can do is when we start to have 3D stuff, we can start to provide you with virtual cross-sections and virtual boreholes. So for example, this is a screen, again, you can get on our website. This happens to be Glasgow. You can pull in the different digital maps and you can start to get virtual boreholes. And this is incredibly important for lots of different uses, particularly within the engineering world and discipline, to be able to do this. So you're not just relying on the huge amounts of boreholes that we have. We can now start interpreting in areas where we don't have boreholes. The other important thing to think about as we go forward is that from where we used to be 5 years ago, where the geological map was based on observation, we are moving now to data mashing. So in other words, putting lots of other types of data. And we've already had ECL highlighting Earth observation data and the things that they're able to do these days with EO data. But there's all sorts of data that we have been using to mash up to get new and exciting products and services from the Geological Survey. And there's just a couple here that I've shown. I mean, debris flow forecasting up in Scotland, using weather data, understanding slope angles, looking at INSAR and tree data to understand swell shrink and the impact that swell shrink is going to have, putting climate models in with our Geoshore data set, which is a ground stability data set, to understand where during changes in climate we might get changes in our risk ratings for ground stability data. All of that is possible because we are looking at how we reuse the data. So what is fair data? This is findable, accessible, interoperable, and reusable. And this forms the heart of our data strategy going forward, is moving into this. And although this all seems very, very simple to do, it's by no means simple. Geoscience data has multiple formats. It's highly complex. It's becoming bigger and bigger and bigger as we get real-time data. UK Geos, this subsurface energy laboratory that we're building at the moment, is a key example of that. This also forms a key part of the work that we're doing with the Geospatial Commission at the moment. The other thing is about making it reusable means trying to open up our data. And although I will be the first to say that open data isn't free data, it's really important to make sure that our raw data is easily accessible, that you can find it at your fingertips, that our users are finding it easy to use. And that brings me on to just showing you some work that was done a few years ago around the visualization of that data. So here are the open version of our ground stability products, and showing how hex grids were used. And I believe this was Henry and Carl who did this work. It is incredibly exciting in looking at different types of visualization techniques in how you can display data in a clear and factual manner that makes it useful for people. The other thing that's really important going forward is co-designing solutions. So when we're looking at new types of map products, we have to start understanding what innovation is. And the center of innovation is understanding a user's problem and providing a solution that can be delivered to them. So it's not a solution that is just a scientific idea that's great. It's actually tailoring our science to our users' needs. And sometimes that means that we have to make a balance between high-end science that's very exciting to a much more simpler, easy to use solution that is good enough. So in other words, a minimal viable product. And getting that balance right is something that our product design teams are doing an awful lot of. The other thing that I want to highlight here is the fact that we're using a lot of story maps now within Esri. So getting our maps to tell much more of a story using these new facilities within things like Esri, for example, going forward, has really brought to life a lot of the data and information that we have. The other thing we have been working on for many years and links in with the 3D session that we're going to have later is about how we use virtual reality. How do we visualize it? And for many years, we've been developing our own software, GeoVisionary, using gaming technology. And the key thing here is about how it brings together data from all sorts of areas. So engineering data alongside your geological data to enable better cooperation and understanding. And the way forward then brings in our UX team. So we're looking at how do we make our VR tools more web accessible? Do you need specialist hardware? Getting away from specialist hardware or software, having it as software as a service, simple navigation controls, because we are the iPhone generation. We like to be able to pick up a piece of tech and just use it. nobody wants to spend a lot of time learning how to use things these days. So if we want mass take up of these things, we have to keep them simple and we have to keep them intuitive. Simple and customizable data visualizations are the key way forward and a big area of what we're looking at. To do all of these things that I've talked about, we have to have our underlying infrastructure. And I felt that quite often we don't I don't put many slides up often when I'm doing presentations around the underlying infrastructure, but I thought it would be really useful to highlight what goes on behind the scenes and how everything is being pulled together. So this geoscience hub, or the geoscience data hub, as we like to call it within BGS, is a cloud-based system to enable us to start pulling all our data in. And you can see how we're ingesting. We're looking at many more ways of automating our ingestion processes. How do we stream in our sensor data and networks as those are being increased? And then how do we push them out? And what are the services that we are going to do? And you can see here how many different services that we are pushing our data out to. And it very much is, maps are still key. The Geospatial Commission is very clear that people like location based data. But it is also about providing numerous services to enable people to use that geospatial data appropriately. So in conclusion, what I would like to say is that my objective as Chief Digital Officer at the survey is to put digital at the heart of everything that everybody does at BGS. And what I like to say is that we are enabling 4.5 billion years of Earth history to be part of our digital future. And I will end there and take any questions. Thank you.
Thank you very much for the presentation, Kate. That was really good to see. I think you really highlight how everything's really a big jigsaw puzzle, and without one bit, it just doesn't all fit together. And again, geology as well with 3D, you just need 3D with geology to understand it. It's just so important, and I think you really highlighted that there.
Thank you.
There aren't any questions in at the moment, Kate, so because we're running a little bit behind, I'm just going to press forwards. I know you're going to be at the networking event later on.
I will.
So
I will.
We will catch up with you there, and people will have some questions for you there.
Thanks very much. It's been a pleasure to come and talk. So thank you.